All right, so we're going to do number 21 from practice test 1. Our question identifier is 3.2.34. So this would be from chapter 3, section 2. Number 21 says the dot plot shows heights of college women. So it's the dot plot right here. And the mean is 64 inches. So we have been given our X bar, and that is 64 inches. That is the mean of our sample. The standard deviation is 3 inches. So S, or standard deviation, is 3 inches. And we then want us to complete A and B. So I put the Z-score, the calculation, the formula for it here, because it asks us in part A, what is the Z-score for a height of 64 inches? So to find a Z-score, you need 3 things to find it, or these are the 3 things on the right side. We have our observation value X. In this case, for A, the X that's given is equal to 64, okay? We were given X bar, that's our mean, so that would be 64. And then our standard deviation was 3, and that's our sample standard deviation. So I left this picture up here because I just kind of wanted to put this together. This is from the previous problem. But what we had done is we had our mean here in the middle because we looked at the empirical formula. And these things really tie together because this was our X bar, right? And then we found like how much data was 1 S away and how much data was 1 S away, how much was 2 standard deviations away. And then, you have your, oh, so there's supposed to be minus there. Let me write it real quick. So you have your 2 standard deviations and then 3 standard deviations away. And so when you start talking about Z-scores, Z-score of an observation is going to be, it tells you how many standard deviations it is either above the mean if it's positive or below the mean if it's negative. So like taking what we did here, this would really correlate to, this value right here, would correlate to a Z-score. Oops, trying to write on it and I didn't do it. This correlates to a Z-score where Z equals 1, okay, when you have 1 standard deviation. And then by a similar ID, this would be, Z equals 2. And so you can tell how many standard deviations above and below the mean something is. But on the other side, so let me do that too, so you can kind of see all this tough stuff has together. Down here, this one is a Z-score of -1. So when it's negative, it's going to be below the mean. And then here, this would correlate, my yellow just went away. That would correlate to Z equal to a -2. So we're going to find the Z-score for part A, and then we'll kind of look at that. And then we'll look at part B as well. But just keep in mind, it really relates back to that, what we were doing before. So we're trying to scale this, and it doesn't have, it's called standard units, I think. Let me double check. Because you don't have a unit on it. It's going to work for anything. So the units are in the original problem, but we would just say that these are standard units for this. So let me continue. So my Z-score. For this one, we're calculating the Z-score. So that's our desired result. We're going to put in our observation. For the A, it was 64. We subtract the 64 that is the mean, and we divide by 3. So the Z-score of this, since this value is actually the mean, it is 0 standard deviations away. That makes sense, right? That value is the mean. That value is right here. It's the X bar. So that would be Z equal to 0. And so that's the center of our, that would be the center of our bell chart. That's like the peak, okay? And then for part B, we're looking for what is the height. So this time we're looking for that observational value. We're given the Z-score, so -1 equals, and there's actually a couple ways you could have done this, because -1 correlates to 1 standard deviation below, right? So you could have do it that way as well. But you could say -1 equals, and then X, the observations, what we're looking for, minus the 64, that is our mean from above. Oops. And then we're dividing this, my iPad moved, I apologize. Dividing it by 3, which is our standard deviation. So you're going to see in a second, it would have been the same as if we took 64 and just subtracted off 3, right? Because that's the same as what we had up here. But we'll just do it this way as well. So what we're going to do is multiply this, because it may not be a perfect number always. So you want to know this process. I did it earlier in class. It was almost. So 3 times that's -3. Anytime you want to solve for a variable, you want to isolate the variable. We begin by clearing any fractions. So the LCD of both sides is 3. I have x minus 64. Now to isolate x, I'll move the 64 away since it's being added or subtracted. Use additive inverse. You're going to add 64 to both sides. And that leaves me with a 61 on the right. So x equals 61. So kind of like I was saying a minute ago, another way to do it, and it's good on this one because this was a nice whole number. So this was exactly 1 below. If something has a z-score equal to -1, again, that means it is 1 standard deviation below your mean. So what I want to do then is I want to take my, we're going to get here in a minute, we're not there yet. I'm going to take my x bar. So I take my x bar and I subtract 1s, or it would be 64 minus that 3, which gives me 61. So you can see, I mean, those things, they all kind of tie together what we did in the previous example. I need to rewrite this where you can see it. I apologize. My phone keeps beeping. X bar minus 1s is going to be 64 minus 1 times 3, which gives me 61. So you get the same value. Okay. So it would be 61 inches because it was height and we were looking for the height in inches. All right, so once again, that was number 21. And that's just looking at how we can use the z-score. We can calculate it from a given observation. We can also use the z-score to find the particular observation that lies a certain standard deviation distance away from the mean.